And I think this can be further explained. Let me just talk that in depth so everyone can follow me. Okay, so what I'm doing here, is that if you want to combine this with the hypothesis testing, is also fine because this is normally we do, right? As a both is what we normally do. So we kind of want to prove that the B1 is not zero. If it's zero, the regression won't have any meaning because the coefficient is zero. So what are we gonna do if its coefficient is zero? Well, there will be no regression. So we don't want that to be zero. We want it to be anything rather than zero. So we kind of need the alternative hypothesis of B1 not equal to zero, and we want to reject the non-hypothesis of B1 equal to zero. We want to reject that. So we compare the B1 we are analyzing right now with zero. We want to see the variance of that, and we are kind of standardized using the T. And if that's even if B1 just a very tiny number, and we adjust the standard deviation of that, even that small number still is really unlikely to happen, because say that the t is to 100, say that it's too big, it's really unlikely that it will happen. It's really unlikely that will happen, so it won't happen. So we kind of reject b1 equals to 0, right? If b1 equals to 0 and I took the sample and I found that b1 is not equal to 0, and I find out that this really unlikely will happen, which means that your conclusion is wrong. So the b1 is not 0. If it's 0, then why am I getting a different number, right? So we kind of reject that and we accept that the b1 is not equal to 0. Only b1 not equal to 0 can this thing happen. Can I get the b1 not to 0 data, right? That's the logic behind the normal hypothesis testing. And of course, a lot of students got confused when I just changed 0 to 1. I think the logic behind that is almost the same. You just need to go through that one by one. I go through that really slowly. I want to check whether B1 is not equal to 1, right? Because what I really want you to do is that I want to check the B1, if B1 equals to 1 is unbiased estimate. So you can kind of go both way, right? The first way is this. You kind of just use the above method. The non-hypothesis, you just change the B1 to 1. Okay, everything is just so familiar to you. So just write the alternative hypothesis of B1 not equal to 1. So use the same method. You calculate the T, B1, subtract, and subtract by 1, and calculate the standard deviation. And when you divide by S, you got say that you got 100, which means if B1 is equal to 1, and I got the say the b1 equal to any other number equal to 2, equal to 3, even just a really tiny difference from 1, you still got the probability that is really unlikely to happen. So if it's really unlikely to happen, why am I getting a different b1 here? Let's say that I got a b1 of a 2. Why am I getting a different b1? Why I'm getting 2 in our estimate? Which means that it's really unlikely this kind of thing will happen. So b1 equals to 1, we can't say that b1 equals to 1. There must be b1 not equal to 1, so I can get that. Okay, so we reject that. We got the alternative of b1 not equal to 1. And at some quizzes, it will just test you this way. When you calculate that, you might get a really small number, say that 1.2, as I mentioned earlier. So it's a really small number, and it will not fall at a rejection area, but rather something like this. So you can't reject that. You can't reject that. Once you can't reject that, so B1 must be 1. Or why am I getting this data and really familiar with the B1 equals to 1? Say that you got the 0.9999 as the B1, and this B1 is really close to 1. And if that 0999 or 0998, something like that, if you think that is the B1, why this thing happen so commonly, and I can't reject that. So it must be B1 equals to 1, right? So that's the logic behind it, and I think that's pretty much explained this method. Okay.